So now in this video we have an integrated circuit with 4 AND gates in it. Quad AND gate, it's the 74HC04. HC is basically the type of transistors in it. We're not going to go into detail on that. We're just looking if we need an AND gate, then we could use this integrated circuit. So the output is low right now. We have a couple inputs there. I just have a jumper there. I can give a high input with that jumper. Now I'm giving a low input. This also has a low input right there. And I'll turn the voltage up. It's just a voltage divider. And there you can see that the output is staying low. The only way we can get the output high is if that input is low. And since there's two inputs, I mean this is floating right now, it's picking up stray signals. If we get that input high and that input high, that's the only case where the output is high. Any low equals a low output. So now we're going to zoom in on the schematic diagram that I put together. So the integrated circuit, I got it from a 7400 kit. The number there gives you the information for what the integrated circuits are there. So there's a 4, that's quad, 2 input, so there's A and B, and gates. And so AND gate means if any input is low, the output is low. Since there's 2 inputs, we have 4 conditions we could have. Both inputs have to be high in this case for the output to be high. So close enough to 5 volts to get an output that is close enough to 5 volts for the red LED. If one is low enough or the other, or both of them, then the output is going to be low. It's going to be ground close to 0 volts as possible. So I'm using 5 volts here. It's been a long time since I looked at the schematic diagram. We're using 5. Both one input's high, one's low now. So the output's low. We got the blue LED. Now the red LED is lit up. You can see we got a lot more current, just because with these LEDs, the red LED doesn't get as bright as the blue LED at the same current. There you can see that the blue LED is bright, even though it has a lot more current going through it right there. So we're using number 2, A and B, for the inputs, and we got Y there. It's an output. So you can see 1 of 4. I'm not using 1 though. You can use 2. But sometimes there's schematic with 4 AND gates. So it's going to say 1 of 4, 2 of 4, 3 of 4, 4 of 4. You can use the one that they numbered there, but you don't have to. You know, it might make it less confusing if it's a complicated circuit if you use 1 of 4 where they say 1 of 4. So you know what attaches to those pins if it's kind of a complex circuit. But in any case, this is just a demonstration circuit. We can use this particular integrated circuit to either sink or source 25 milliamps of current from each output, but you want to limit the total current to 50 milliamps. So if you are using about 25 milliamps with the outputs, then you'd only want to use 2 of these. If you're using all 4, you know, keep each one of them closer to 10 milliamps, so you don't exceed the total of 50 milliamps. In any case, that's about it. I think it's a good idea to get these integrated circuits and build little practice circuits with all of them. Of course, the vast majority probably of integrated circuits have truth tables, and basically whatever that type of integrated circuit is, it lets you know the different states you can have for the inputs. Usually there's 2, but there's some other ones, and it will tell you what the output will do in response to that. So hopefully that makes sense. In any case, that's it for this video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.